Hello, my name is Hector Perez. Welcome to this new video in which we're going to explore what the new features of Blazor in .NET 8 are. I'm a Microsoft MVP with more than 10 years of experience working with the .NET platform. If you want to follow me on social networks, you can do so through the links that I leave you in the slides. First, let's remember what Blazor is or what we can do with Blazor. Well, Blazor currently allows us to build enriched and interactive applications through a graphical interface using C#, HTML, and CSS. It is fully integrated with ASP.NET Core. We can use or it has a model to use powerful, reusable components. It allows us to easily and quickly handle graphical interface events. It has support for two-way data binding. It also has some pre-built components for forms and validation. It allows us to deploy large sets of data quickly through virtualization for the best possible user experience. It allows us to build installable web applications and also support offline scenarios. It has some tools that allow us to build applications quickly through a feature called Code Reload. It also allows us to write C# code to have interoperability with JavaScript when required to access functionalities that are more specific to the web platform. The great advantage of Blazor is that it allows us to build web applications quickly using a single language, which is C#, a single framework, and through a unique compilation system. All of this is provided by the .NET platform to create these types of applications. With this new version of .NET 8, we already have a complete web graphical interface stack through Blazor, meaning we can combine server and client parts, which is what we will see a little later. In this list, you can see some features that we will be examining throughout the video, such as static server rendering, enhanced navigation and form handling, streaming rendering, enabled interactivity per component or page, and auto-selecting the render mode at runtime. These are some features that we'll be covering in this video. Firstly, let's recall what Blazor is, or what models existed before this .NET 8 version. Previously, we could host a Blazor application on the server with a .NET server. We could establish a connection via Signal-R to the application or the client's browser. That is, the client only received information from the server, with the server handling all processing of logic, constructing the HTML code, carrying out constant updates, etc. The client only received this processed information for display to users. We also had a second model through WebAssembly, in which the application was hosted on a server, but the application was eventually run on the client's side. This means that the browser was in charge of executing all the application's logic. All components and runtime were downloaded for a local client hosting, giving the clients a fast experience because the application was essentially downloaded in their browser. With this .NET 8 version, a new model known as Static Server-Side Rendering or SSR is included. What does this model enable? Well, it allows for a traditional model in which the server creates the HTML code, sends it to the client, and the client receives all this processed information for user display. That is, the client sends a request to the server renders the website, returns it to the client, who receives as a reply the code that the user will display. However, this is static content and there is no form of interaction, as the client only receives this static portion once. If you need to do some post-processing or interactive processing, this cannot be done because the content is static. Well, it can be done, but we'll see how later on. So, what does this allow us? Well, first of all, it allows us to have some scalability, since on the server side, the server will not have to be processing the information. We'll decrease the server's load. This load of processing the information to send the results or updates to the client. It will also allow us to present information. This model is very useful when we don't need a type of interaction, such as displaying news information on a blog, etc. Navigation will be through links. We can also use forms to input information. When is this scenario or static SSR model not useful? Well, when we need a type of enriched interactivity through event handlers. Also, when there is a need for real-time updates, this model is not very useful since, as I said before, there is no native interaction. But in case we need a feature on one of the pages, we can enable one of those features through features called Interactive Server or Interactive WebAssembly, which we'll see later on. So, in a traditional model or before .NET 8 version, a template was chosen to work with Blazor through Blazor Server or Blazor WebAssembly, and the entire project was configured to work with either model. This was referred to as global interactivity and was available from the .NET 3 version to the new .NET 8 version. What does this mean? Well, if you have an application with either of these approaches, you don't have to do anything special or these models don't become obsolete. They continue to be fully valid for you to keep using with your applications. This does not change at all. With the .NET 8 version and later, what happens is that the application, if you choose this SSR template, will be static by default. However, you do have the option to mark a component or a group of components to behave in a specific way if you need any type of interactivity. For instance, in this example, the chat component will behave as if it was Blazor WebAssembly, but you can also specify certain components to behave like a server, meaning they won't download to the client but will only function on the server side. So you have the ability to determine how each component will behave. This flexibility is a huge advantage offered by this new model we are observing, known as static SSR. Another thing that we can do is enable this behavior per page, or we could also enable the interactive behavior per component. Let's see a demonstration about static SSR going to Visual Studio. Okay, I am now in Visual Studio. I am going to create a new project. You can see that there is a new template called Blazor Web App. We didn't have this template before .NET 8. Let's select it and then we'll give the project a name, for example, SSR Demo 1. Note that as part of the features of this template, we have the .NET 8 framework. We have characteristics that we always had, but now there is a special section that we never saw before, which is the interactive rendering mode. I'm going to specify that I don't want any interactivity in the application to start with, so you can see from scratch what we're going to do. For the location of interactivity, we can specify whether we want it per page, per component, or globally, which is how Blazor worked previously. I'm going to leave the page and component option selected, and I want to include the sample pages. I'll click on Create, which will create the project in Visual Studio. What we see on the screen. Let's run the application to see how it behaves by default. Here we have the application. It's a standard Blazor application, like the one we had before, except in this case you can notice that a component that was used before called counter does not exist in this template. We'll see why later on. What does exist is a page called Home, which shows us the main page. We also have this tab named Weather, where we have this information that we can view on the screen. Okay, with what we've seen, let's return to Visual Studio, and previously I prepared a component for you to see in action with this model. I'm going to place it as part of this folder called Components. Okay, here we have the component called Color Switcher. I'm going to open it quickly. It's a very simple component, with only an H1 and H2, a set of divs. The code part consists of just 3 fields that will allow us to store a different value. The idea of this component is that we can have a color in a red value, a color in the green value, and a color in the blue value to form a final color. To add this component or to see it in action, let's go to the page or to the component called Home. As part of this component, I'm going to add Color Switcher. Just like that. With this, I'll start the execution of the application. Let's wait a few seconds, and here we have the application. You can see that we've correctly added the component to the home component. However, if we start to play with the sliders that should modify the final color obtained from the set of the 3 colors, we see that absolutely nothing happens. The value doesn't update as such. This is happening because, as I mentioned earlier, we are using a static model in which the server took care of processing the HTML code to return it to the client. Once this code is returned, it ends its task and does nothing more. Therefore, we are receiving that final HTML code, but there isn't an interactive part because we specified it like that. However, if we go to the Weather tab, you can see that every time we open this tab, a message that says loading appears. Why is this happening, you may ask? Why isn't it working here, and why do we have some level of interactivity here? It seems as if JavaScript or C# code is running behind the scenes. Well, this is happening due to another new feature of Blazor called Streaming SSR. It allows us to indicate to the user that something is happening before getting a final result, before receiving that final response after processing, for example, from a database or after an API call. This allows us to have a quick initial load, a fast rendering of the graphical interface, or a quick update. It also allows us to initiate a parallel reload of static resources. What we need for this to work properly is to have some kind of graphical interface that the user can watch while waiting, to give the impression that something is happening behind the scenes. What we are told here is to use this resource when reloading the resources or to show the user something when there is a certain delay. That's what we're going to do next with the demonstration. Suppose as part of this component, we want to invoke a service that returns a random color. I have prepared a source code, a section of code, for better appreciation of this. Here it is. You can see that what we are simulating here is that when the application is loading, we are simulating a server request to obtain a random color for each one of these values. So, to make this work correctly, we must modify the HTML code to indicate what will be displayed in case we don't have or do have a certain specific value. What do I mean by this? Well, as you can see initially, each of these fields has a value of -1. What I'm going to do is check if the value of any of these values is -1, which means that a color has not been set, so we will display some type of content. I already have a code snippet that I'm going to copy and paste to save time on this part. Okay, it's the code that you can see here. What we are basically doing here is asking if the red field has a value of -1, then we're going to display an image called loader.gif. Otherwise, we'll display the final content, which is the deployment of all the other controls we saw earlier. I'm going to create a new folder in www.root called img, in which I'm going to copy and paste the image, which is in fact a GIF image. Then, what I want to achieve is that, as long as this red field does not have a value assigned, the animation is displayed and, otherwise, the final control is displayed. Let's see how this behaves. Okay. Let's update the page because maybe it did not display correctly. You can see that we have the same behavior as before, meaning it is waiting 5 seconds while one of the colors gets loaded, which we are simulating. To enable this streaming SSR feature, we need to add an attribute as part of the component, that is this attribute we see here, attribute stream rendering. With this enablement of this attribute, let's see the difference with the application. You can see that this animation appears from the start, which looks very dynamic, and once the final value of the field is obtained, we are now indeed displaying the component as such, with the final result after completing the request. As you can see again on the screen. Remember that we are using a static approach, in which there should be no sort of interactivity, since it is static content. However, thanks to this feature called stream rendering, we can now show the user some type of animation, some type of content, while the initial loading of that final content is being carried out. Moving on with the slides, let's look at another feature called enhanced navigation. It allows us to have a similar type of responsiveness that looks like a spa, but without the need to use a spa template. What does this cause? Well, it makes the page loading faster, with fewer HTTP requests, that we can retain the information of most DOM elements, and that we can enable this feature in any DOM subtree. Remember again, we are working with the template which is static. This would be very difficult to do manually, but with this feature enhanced navigation, we have by default the ability to enable this feature for different elements. To carry out this demonstration, I will proceed to the file, which is found within Components, Layout, and the file is named navmenu.razor, which is a component. Next, or inside this nav element, after the pair of items in the navigation bar, I'm going to add a form item within an input type equal to search, with a title equal to, for example, search term. Okay, with this, I'm going to start the application again. What I want you to see is on the left side, we already have this form that we added. I will write a text, and what will happen is, if I go to a different page, the content of this text box is automatically deleted, because this is the common behavior it should have since the whole page is updating its content, and therefore that piece of text disappears or gets lost. What we can do with this new Blazor feature is to add an attribute called data permanent as part of this form. Let's save the changes. There are several attributes we could add for different use cases. This can be seen in the documentation. But in this specific case, if I start to write some kind of text and switch to a different component, you can see the text remains, thanks to us using this attribute called data permanent. Also, another thing we could do is work with static forms in this SSR model. This allows us to accept and validate text, or better, input data on static SSR pages. We have all the abilities of a form or an edit form. We also have the same APIs for the part of interactive components. And lastly, these forms also work in collaboration with streaming SSR. I will not demonstrate this feature because I want to show you the next one that I find much more interesting, which is interactive components. What will this part allow us? Well, we will have all the power of Blazor interactivity, arbitrary events, and real-time updates. What we can do is mark any page or component with the server model, WebAssembly, or both. We will see this a bit later. It also works perfectly with the improved forms and navigation. But as you can probably guess, when we use Blazor WebAssembly or Blazor Server, to see either of these models, we need a WebSocket connection, or the information must be downloaded to the client. Let's see how we can enable this part of interactive components. I am going back to my demonstration. To enable this part of being able to assign a component to behave like Blazor Server or Blazor WebAssembly, well, we will start first with the Blazor Server model. What I'm going to do is go to the program.cs file. On this line that says builder.services.add-razor components, I'm going to indicate that I want to add the interactive server components through add interactive server components. In this part, on this line where it says app.map-razor components, I am also going to add another method called add interactive server render mode. With these lines that I have added, we now have the capability to enable a component to behave as if it were a Blazor server component. How can we do it? Well, we're going to go back to home, where the use of the color switcher component was located, and we have an attribute available called render mode, which we can assign to interactive server. With this attribute that we are adding here, we are already indicating that we want this component to behave as if it were a Blazor server component. Another thing we could do is cut this attribute and go directly to the component and add it as part of the component. However, this is not highly recommended. Here we would have to remove this equal sign. This is not advisable because if we wanted to deploy this component for a third party to use, we would be forcing whoever uses the component to use this rendering mode, which would limit a bit what the end client or the end user would want to do with the component. Therefore, it is recommended that when it is not a page type component, use the other form that we saw earlier, which is adding the render mode attribute and the rendering type, which in this case is interactive server. Okay, with these changes that we have made, we are going to start the execution of the application. Okay, you can see that we have the component here. And on this occasion, when we start to play with the slider, you can see that we have successfully changed this div, which is taking the final color that we are obtaining from the combination of the three sliders, which indicates that we already have a type of interactivity as part of the component. If we inspect as part of this page the network part, I'm going to update the information. You can see that as part of the resources of this page, we have here a signal R connection. We can go to the part of the messages. Let's go all the way down and look at how when I start, well, I am going to remove all the content so you can see it better. And if I start to play with the slider, you can see that a set of binary messages are added, which tells me that there is a signal R connection that is allowing me to update the information of the component thanks to this signal R connection. What you might be wondering now is what happens if I want to use an approach with WebAssembly. Well, in this case, I'm going to create a new project. I'm going to select the same Blazor web app template, but this time what I want to select is a type of interactivity through WebAssembly. I leave the other data as default. I've only changed the type of interactivity to WebAssembly. I click on Create. Once the project has been created, you can see that we have a couple of projects in the solution. The first project is called Blazor App, and the second is called Blazor App.Client. This first project will contain the components that are of the Blazor server type. For the Blazor WebAssembly part, a second project will be created that will maintain all the components that are of the WebAssembly type, and this is the recommendation. If we expand this pages section, you can see that we have the classic counter component, which essentially allows us to increase a field every time we click a button. Here it is. Now, if we wanted our component to behave like a Blazor WebAssembly type, we would need to add the component to this project that ends with .client. But before that, I want to show you that in the program, a couple of methods have been added. The first one is add interactive WebAssembly components, and the second one is add interactive WebAssembly render mode. Similarly, since we have a separate project for the WebAssembly component, there is an additional line that allows us to add additional assemblies through the component type, which in this case, the counter that has already been created, and we obtain the final assembly. With these lines, the functionality of Blazor WebAssembly is added so that we can work the components in this mode. With what we have done, I'm going to add the component as part of the client. Okay, here we have it. I have copied and pasted it into the pages folder, color switcher. We have the same code we had previously, including the stream rendering attribute. Now, what I'm going to do is go to the main project, Blazor App 8. I'm going to Pages, Home, and I'm going to add this component, which is Color Switcher, but adding a render mode equal to Interactive WebAssembly. Okay, with that prepared, I'm going to start running the application to see what happens. I need to quickly go back to the project as I forgot to add the image in www.root. Okay, I have added the image. I'm going to start running the application again. Now we have the component here. You can see that we have proper functionality again. I'm going to inspect this page. I will go to the network section. I'm going to refresh the page again. On this occasion, we don't have a signal R connection, but what we do see is that a lot of things have been downloaded, including the .NET runtime. This suggests we are using Blazor WebAssembly. You can see we don't have the signal R connection we had before. So we are using the Blazor WebAssembly model for this specific component, adding interactivity to the component. Okay, finally we have a model called Auto Mode, which allows us to use WebAssembly without the cost of the initial download. What does this refer to? Well, traditionally, as you can remember, in the Blazor server model, near instant execution is carried out for the client because the server handles the processing of all the final HTML code. In the case of Blazor WebAssembly, the initial download may take a bit because all the necessary components are downloaded to the client. So, with this automatic mode, the aim is to take the best of both worlds. That is, to show the user a fast initial load through Blazor server, and behind the scenes, allow the components to download automatically for them to have a Blazor WebAssembly model once the components download has been carried out, in such a way that it takes the best of both worlds. There is less server load because only an initial display of the component is carried out, and then the connection is closed so that the client can handle all the processing. This allows us to utilize the server while carrying out caching of the WebAssembly files and then use WebAssembly on the next visit. The components must support WebAssembly. This is mandatory if you want this automatic mode. This means that the component or components must be found in the Blazor WebAssembly project and use API endpoints for the data part. Let's go to the demonstration. I'm going to stop the execution of this application. I'm going to create a new project using this template again. But this time, in the interactive rendering mode, I'm going to select Auto. I'm going to leave the rest of the configuration as I've used before, then I create the project. You can see that we have two projects, the Blazor project where we would have the Blazor server components, and the project where we would have the Blazor WebAssembly components. Also, in the program.cs file, you can see that a pair of lines have been added that will allow us to work with both types of models. Also at the bottom, we have included these lines again to work with this model. Once again, as part of the WebAssembly project, I'm going to incorporate the component I have been working on into this folder called Pages. Okay, we have here the color switcher component and it is correctly placed. I'm going to go to program.cs or more precisely to the component within Pages called home.razor. Here we have it, and what I'm going to do is add color switcher at render mode equal to interactive auto. That's all that's needed for this component to behave in this way. Remember, the component has to be in the client project, that is, where the WebAssembly type components are. With what I've done, I'm going to start executing the application. Here we have the application. Once again, I forgot to add the image. I'm going to do it quickly. Here we have the running application. What I'm going to do to demonstrate how this model works is copy the URL and go to a new incognito window. I'm going to the network section where there is currently no information. I'm going to paste this URL. You can see that the application is already loading as part of this tab. You can see that as part of the resources we have available, okay, here we have the component. We have a signal R connection. I am going to remove all the messages. If I start playing with the slider values, you can see that we have a series of messages again, which indicates that we have a signal art connection to work with this component correctly. That is, we are using a fast initial load thanks to the use of Blazor server. However, when I refresh this page, you can observe that once the component has been loaded, here we have it, we don't have the connection we had previously, but on the contrary, we are already using the components with which we can work with Blazor WebAssembly, like for example the .NET runtime. We don't have the signal art connection we had before, indicating that this component is using auto mode. That is, Blazor server was first used for the initial load, and once the components have been downloaded, the Blazor WebAssembly model is used to use the component locally, giving us great flexibility and the best of both worlds to be able to work correctly with Blazor. These are some of the features of Blazor in .NET 8. I hope the video has helped you to understand more about the new features of Blazor in .NET 8. If so, I invite you to give a like, it would support the channel. Also subscribe to the channel and hit the bell to get updates when a new video about .NET, Blazor, .NET MAUI or any other technology in general is released. See you in the next video.